Dia yang sama je.
Live streaming is on.
Okay. So I like to share my screen. Okay, now can you see my screen?
Yes.
Alright. Okay. Okay. For today's topic, inshallah I will cover division 3. Okay. As the name suggests, division 3. So the models look like a tree, and then in division 3, okay, it split the data into branches. Okay, as we see at the top of the slide ni, this is like a tree. Okay, um, the and then for the variable or the features here, we call it node. Okay, the model itself is look like a tree, but the root of the tree at the top of the model, and then the leaf node, we call it node, that the leaf node at the bottom of the tree. So and then the node at the middle, we call it internal node. And then for starting from root node, it will be split the data to branch. So the arrow there, we call it branch. So decision tree, it split the data into branches, homogeneous as possible. And then from division tree, it mapped the data. You can see that it mapped the data. The important variable will be on the top of the tree, and then the least important variable will be at the bottom of the tree. So overall, it is a supervised machine learning. We have an idea what we want to look at in the data, whether we want to do, like, if we have numerical data, we can do prediction like regression, and also we also can do for binary outcome or categorical data for classification. There are several algorithms. Sometimes we call it like introducer, I think, algorithm. It depends on the type of the data, and also whether they can do boosting or pruning. For example, like C4.5, we can do boosting and pruning. For ID3, we cannot do for boosting and pruning. Other than that, like type of data, for ID3, we only can use for the categorical data, but for the others, we can do for numerical data as well. Like for example, other than that, like missing value, so C4.5 can handle missing value, and CUT also can handle that, and also like the impurity that they use, like Gini, they use for C4.5 and CUT, but for ID3 they use entropy for the method of splitting of the data. Why decision tree? It is more robust compared to like neural network, for example. And for the interpretability also, it is easier compared to the blackboard neural network. And also compared to like random forest, it is the time used more shorter compared to random forest. And decision tree can tolerate with missing value, and also it is not really sensitive to the outliers. And also the last one, like logistic regression, we required to fulfill the linear relationship for numerical data, numerical independent variables toward the outcome. But for decision tree, we don't have to check for the linear relationship. Okay, so for splitting criteria, they are this is the common type of method used. One of it is Gini index and one more is entropy. However, if you are using like both method, usually your result will be almost the same, and the difference between the two methods is only 2%. However, because of the log function in the entropy formula, because they have like log using base 2 log here, it requires more time to calculate for the entropy compared to Gini impurity. Okay, okay. When look at the formula here, this is so it calculate for this index or entropy. It calculated for each node. For each node, even in the root node also they calculate for the Gini or entropy, either one. Okay, so for Gini index, the formula is 1 minus the summation of probability for each class. Okay, I will show you later how to calculate it manually, and also entropy is like minus, this is the probability for for each class we have to calculate for positive and negative, and log base 2 and using the same probability for the entropy. So we use the same the same number for one for the log and one for the, we have to multiply that value. Okay, so if you have smaller value of the entropy or the index, the data, meaning that data is more pure compared to you have higher value of the index, both index. Okay, this one. Before that, I would like to share with you how to calculate it manually. Is that okay? Okay ke? Okay lah ya. Okay, so for example, very like for it a simple example. For example, we have 14 sample. Among 14 sample, they are and our outcome is binary, yes and no. Among the 14 sample, there are 9 of the outcome is yes and 5 of them are no. Okay, so how to calculate for the entropy? We start first with entropy. How to calculate that? We just get the value of the positive, okay, the yes one, you divide by the total number of sample, the n, 14, log 2 here, okay, and then you log the same number of the probability lah, 9 divided by 14, and then you minus for the negative one. Now you calculate for the negative, and is 5 for no, negative is no, 5 divided by 14, and then the log 2 base 2, the same number, and then you will get 0.96. Okay, actually we can calculate it manually like that, but because maybe I think I'm better using Excel, so I also like provide the formula lah using Excel, because sometimes you don't have to calculate, you just put the number and then we can get the entropy for each node. We don't have to calculate. We just put a number, how many yes and no in the Excel, and then you can get what is the entropy. For example, here yes is 9 and then no is 5. So you will get the entropy is 0.94. So you can actually, this is the right number lah. Maybe this one I have wrongly calculated. So 9495, right? The total. Okay. So this is This one is entropy as so this is for this node. Okay, and then for example like 6 2, you just click here, and then you can get what is the entropy, 0.81. So this is actually actually I use the same formula to get the entropy. Okay. Okay, so you also and then we can calculate for the next features or the next uh, node, which is F2. Then we calculate, and then F3 we also calculate that. Okay, for your information, if we have higher value of the entropy or index, meaning that the data is not pure, impure. Okay, and then if we draw a and then if you have like zero value, zero meaning that the data is pure. For example, if you have like one, meaning that one the purity is for example, the probability is 50-50. When you look at the probability is 50-50, like for example the F3, they have 3 for yes, no, they have also 3. So we have higher, like the highest value of the entropy. So the data is impure, it's not pure because it's 50-50. And then the highest one is 1 for entropy, the highest one is 1. Okay. However, if we have like y is 0, for example, yes, we have 0, and then no, we have 6. So meaning that the data is pure. 0 for one class, and one more class, we have higher value. The rest are one more class, which is no, 6. Automatically, if you put the numbers to the formula, you will get like 0, which is the minimum the minimum number for entropy, and Gini, the minimum one is 0. Okay, this one is for entropy. But if we use the same, like the same, the same value to Gini, okay, you will have, for the one, you will have 0.5. Okay, so this one. So use the same, the same data, and then you put all the value to the Gini formula. The highest one you will get, the most impure data, if you are using Gini, is 0.5, the maximum one. So if we plot the data, um, like this, okay, if we plot it, this is P. P is the probability, the x-axis is the P probability of positive class or yes class, okay, positive class. If you plot it by when the probability of positive class is increase, and then the entropy value also increase up to 1. And starting from okay, starting from like the most impure data set, and then it will become decrease by like it is like uh, when the positive class of the probability is decreased, the entropy also decrease up to 0.5. It is like you calculate the concept is the same as you calculate sample size for one proportion, like that. So if entropy, the maximum is 1, but for the Gini, the maximum is only 0.5. Okay, so the graph also look like the same, but only the peak value is 0.5. Alright, okay. So okay, the next one. But if you have we have 3 like this, okay, we have different outcome if we are using different attribute. Okay, so which 3 you want to choose, whether 3 on your left or 3 on your right? So how to like decide which 3 is the best? We use, we apply we calculate for the Gini index and entropy, but how to get that? We are using information gain. Okay, if you have higher information gain, meaning that your tree is better lah. Okay, how to get that? Okay, information gain. Okay, when you look at here, okay, this is information gain. Okay, for the data set parent, parent P is parent node, and we split it. Okay, we split to become child node. So the next one is child node. Okay, so we have child on the left and also on the right. So this is the impurity criterion, whether you want to use Gini index here, ID, okay, I here for the parent, or you also can use entropy. So it's the same. Okay, and then you minus, okay, minus this one is entropy or Gini index for left, this one. Can you see my mouse there? My cursor there?
Yes.
Okay, thank you. Okay, then so this one for left and this one for right. Okay, so we calculate for each node for the entropy or Gini index. However, we would like to, actually I when I read, sometimes they use it like weighted like Gini impurity, like they weight it, because we have different sample size here, like 21 plus 5 is 27, this one is 38. So how to get that? Okay, this one okay, and left total for n. Okay, here I will explain it here. Okay, this one 21 plus 21 positive and 5 negative. Okay, so the entropy for this, if you use the Excel that I give to you, you will get the entropy is 0.71, and then entropy for the left, for the right one is 0.74. So you can calculate that there. How to get the information gain? Okay, it also consider for the parent one. Okay, so entropy for parent minus this one, 26 divided by 64 is actually the total number of this one, the true category. Okay, the total number including positive and negative divided by the total sample, 64. And then multiply by entropy for this node minus this sample size. Okay, this one 38 divided by 64 multiply by entropy for false node. So if you, and then you can get the information gain. Same goes to the next tree, the second tree. You also can get the information gain with the same formula. Okay, this one is clear. Is that okay?
So basically, A1 and A2 is our variable, right?
Okay. This one, yes, our variable. Tapi this one macam contoh I want to do like I have two option lah. Whether you want to put for the first, whether you want to use first variable ataupun contoh yang first one ni gender. For this one is like age kan, more or old or young contoh So I want to choose which one is better kan. Faham tak? So if you have more information gain, I will choose that lah.
So meaning we choose which one will be used as the first split, right?
First split. Yes, betul. And then we do the same for the next maksudnya they do for example we have 5 variables. Then they do like this lah. And then they choose the variables yang have the highest information gain. Like that. Okay. Same here if you are using like Gini also. This one actually I sama lah maksudnya if you have 100 samples, you have to calculate. This one is only macam weighted Gini tau. Actually the same tau. Okay, I will show you macam ni. Gini index ni. Okay, this one weighted average. Okay, this one kan we calculate for Gini for first node belah kanan and then second node belah kiri contohnya. And then we calculate for the weightage average for this one. Sebenarnya lah sama je formula dia. Okay, and then we minus for the parent, we minus this one. And then we can get the what we call it, the information gain lah. Sama juga dengan entropy pun sama. You can get weighted average for entropy and then kalau you tengok dia punya ni pun actually benda yang sama lah. It's 8 divided by total sample. Macam tu sebenarnya lah. And you can calculate it manually juga. Faham tak?
Okay, faham.
Okay, so kalau macam ni we can calculate for male what is the Gini, and for female what is the Gini, and then sebenarnya we average ataupun we weightage. Kita gunakan and then we can get the information gain from the weighted Gini. Okay. Okay tak? That's all lah for the introduction. Tapi for the if you are using R, okay, there are, this is what I know lah, R part and also tree. Tapi kalau kita guna caret, we also can use R part kan. Okay. For the untuk early stopping ataupun what we call it, we want to like prune the tree. The parameter that we can use is mean split. Okay, we can set the minimum number of observation in the node before the algorithm perform the split. Okay, lupa nak beritahu, if our Gini impurity, Gini index is 0, meaning that it's already 0 is already in the leaf node. Macam tu lah. So if if we got like 0, okay, 0 in the leaf, in the node, it's become our leaf node. We cannot have more split after that. Okay, so this is the parameter that we can use, mean split. Kita set the minimum number of observation in the node before they can perform to other split. Kalau kita just biarkan maybe only like 2 or maybe like 5 very small number, they are still split, and then it is prone to get apa panggil tu, what we call it, overfitting lah. Okay, if you have so many variables, you just macam give the tree split whatever they want, very big tree, so it will give us overfitting problem. Other than mean split, minimum split, we also can control it by mean bucket, where we set the minimum number of the observation in the final node of the leaf. Okay, so this one, this is what I know lah. I don't know what is the other method. This one we try one by one, try and error. But what we can like one more, we have like here we have complexity parameter CP. This one, there are like certain suggestion where to choose the number. Okay, so other than that, other than mean split and bucket, there are also max depth, which is the how many like depth in our tree we want. Okay, so the root node is set with that one is depth is 0. So we can set it how many, like if you have more value, meaning that our tree will become very like big or long tree lah. So we can set the how many depth that we want to in our tree. Okay, for this one is actually I not so macam not so confident, tapi this is what I understand lah. Okay, this one complexity parameter. If you know, maybe you can add ataupun can discuss lah For complexity parameter, for the default one in R part, the default is 0. If I'm not mistaken, 0.01 if I'm not mistaken. So it is the minimum improvement before they split to the next one. Okay, for example, this is the tree. So this is the T, the capital T is the whole tree, without the whole tree, without we prune it, without we like cut certain tree. Okay, if we cut certain tree ni, like small tree here, that one we call it pruning lah, prune. Okay, so the small T is that the T that we want to cut, we want to prune. Okay, the small T here. So cost complexity, okay, this one I just take from Wikipedia aja. Jadi I tak berapa confident lah, tapi maybe after this you can like study further ke apa kan. This is what I understand. So as we know that if we are not prune the tree kan, kita tak buat apa-apa, the error will be better lah kan, the error bagus lah. Our error is sikit, small error, because it will split until like the best lah kan, the most pure. So we are not prune it become like larger like this. Tapi if we cut certain like branch, so kita prune kan dia, the error become of course the error is become like higher lah compared to if you are not prune it kan. Okay, so the formula is the error, the prune one, which is higher, prune, after prune is higher, minus the error without prune, meaning that slower lah kan, the error here. Okay, divide by, okay, this one is the total leaf, the T without prune and after the prune. So we need to have like certain, okay, kalau you tengok sini, we have like how to make like cost complexity ni, maksudnya we try to make it like the minimum. Kalau contoh saya nak cakap if we have, okay, if we have, which one is better, error kan? If we have error, more error, meaning that our model is not good kan, so kita nak small error, so numerator ni should be less, sebab kita nak small error. Tapi we are not only consider the error, we also consider how many leaf after prune. Okay, this one. So kalau kita nak small, this one, so we need to have, this one is error, small error, and this one is higher. So this one I'm not so confident sangat tau, tapi I just whatever I know lah, this is what I understand lah. So kalau lah, if we set it like 0.01, if you have higher error, kalau more than that, dia stop splitting. So macam tu lah, faham tak? Sikit-sikit lah So if cost adding another variable from the current node is above the value of CP, the tree does not continue. So stop up to 0.01 only. So kalau lah lebih dari tu, so error dia makin banyak lah, macam tu kan? Tak? Tak apalah Okay. So this is the last one, which is complexity parameter for the pruning of the tree. Okay, our example today, I would like to use data, catenate data. They are like how many variables, tapi this one, the variables is like survival, whether I survive or not. P class is the TCAT class, gender, sex, and age, This one is SP, the sibling or spouse aboard the Titanic. Barge, how many parents and children. Ticket number, fare, cabin number, and port of embarkation. Okay. Okay, let's open the R. Okay, this one. I'm using Artpad. I'm using Artpad. Okay. Actually, I use the data I take from this website. Okay, and then this is all the package and all the library that I use. So, okay, you can, okay, I hilangkan dulu everything. Okay, then library, all the library. Okay, then I download the data from this website. Okay, then this is the data. There are P class, survive or not, the name of the passenger, sex, age, and all the variables here. Okay, and then okay, this one, how to see it. Okay, the row is 1,300, 13 columns. This is this discrete variable, continuous, and then this is a complete row, total observation. Okay, and then I would like to see the data. Okay, we can hear, but it's actually they have missing, but maybe because of the data they recognize like question mark that is not missing, so that's why they state that missing is 0. Okay. Okay. However, when we see the data, okay, all it is the data, it is not random lah. Like you can see here, the P class, they start with 1, and then at the end of the data, the tail, it is all 3. So the data is not random. So what I did, I shuffle the data. Okay, shuffle, so that before we split the data, we ensure that the data is random first. Okay, and then I shuffle it, and then I replace the question mark to missing lah, to NA, because when look at the data, there are certain cell having like question mark here. Okay, so because maybe it's what we call it, maybe it's like recognized as object lah kan, like string kan. Okay, and then after we, because and then now I want to change that, the question mark to number, string to number lah kan. Okay. So now when we look at the data for variable, for example, age, so age just now we have like, but this one we don't want to use, so I don't change it. But for age we want to use, so we change it to numeric, become missing. Okay, then save the data, and then okay, I save the data. Okay, okay. Okay, so this is the data I save already, and then I drop certain variable that we don't want to use, and also I drop the certain the what we call it, the missing data. I also drop, and I did not impute any missing data. Okay, and then we can do the data exploration. We can see like how many survive for certain group. For example, data exploration, and then we create the train and test data set. So we split it. I split for train data and test, like 80%. Okay, then we split it. I set it, make it like consistent. Okay, and then I would like to check whether the proportion of the outcomes split equally or not. Is that okay? Now is it okay kan? Now there's like common what we call it, like common way lah kan, how we want to split and all that. But we know that we have different method lah kan. Tapi our aim is the same, which is we want to split the data. Okay, now I would like to check it whether the proportion of outcome is the same or not. Okay, between all the data set, the original one, we have like more or less the same, 0.4, 40% of yes. Okay, 40% of survive. Okay, then we build the model. Okay, so I'm using R part. This is our y, and then the data that we want to use is string data, and then the method we can use because this is binary, so we can use class, and then okay, this is the what we call it, the outcome lah. Okay, so this is, they already like split it, how many of them survive or not. Okay, and then you can see the R-part model. So this is our okay. So actually for the what we call it, for the plot ni, we can change lah what we want to use. Like you want to use one, there are certain description lah. 1 is what, 2 is what, 3 is what you want to display in our model, in our tree. For example, I put like 0.2, they have description lah kan. You can go to the R-part punya tu, and then they have like different outcome lah. I mean, there are different information. If you change 102, 103, different information you can get from the tree, from the what we call it, from information that you can get from the tree itself. So this one, and then how many of them is go to the next, which is 63% of them go to the, here female is 37. So this is how our tree looks like. Okay, and then okay, this one I did not, I mean I did not prune it, I did not set whatever minimum split or minimum bucket. Okay, this one. But we actually we can adjust it. For me, I will do it like whatever what I did is I do manually lah. Like min split 50. What is the outcome? What is the accuracy? What is the ROC curve? Min split equal to 40. What is the outcome? Min split equal to 60. What is the outcome? So this is how you can like try and error using like this parameter min split or min bucket. Also max depth. Like here is 30, but here it is not reached to 1, 2, 3, 4, 5, 6. Only like 2, 3, 4, 5, 6, 6 only. So this one, if you have like not so much variable like this, I think you can just leave the RPAT do the tree for you without set for the max depth. Okay. However, if you are using like caret, okay, this one like CP also, for example, this one I'm not so sure actually for CP. There are certain like there are one opinion. They said that we have to ensure that the error it is like only like +1 something like that, minus for the error something. I'm not so sure about CP one. Yeah, so this for this one. There are opinion lah how to what we call it, how to set it. Okay, for example, I just want to show it to you. Like for example, model 2, I set it like what is the CP. This one is actually default. Okay, maybe I change it to like 0.2 here. So min split, I think this one not function much because there are not so many variables here. But I try here. So this one. Okay. So this is the okay, what is it? Okay, this one, wait, for this one. Okay, because I changed the CP just now. Now the what we call it, the tree is like only like 2, 3 level only. But I would like to try to this. So this is the CP that I choose 0.02. Okay, this one, if I'm not mistaken, they have like, wait, I try to do like this. Okay. They have like, this is the cut-off point that we can choose for the CP. And then for the caret, we can like detect it. They can give the, for example, like what? They give like suggestion lah. What is the optimum CP that we can use? But here, because I'm not use CP for my hyperparameter pruning, no, I did not use it. Okay, tapi for if caret you are using caret, for example here, okay, they give you like wait, why cannot? Control not found. Try, wait. Sorry for the trouble. No. Then, but it's okay lah. Later maybe I try to make to see what is the problem here. But for the caret package, you can find what is the like the best CP that they can suggest for you. Okay. Okay. After that, after I do the prediction, after I do the model, now I would like to make the prediction, and then do for the prediction for the train data. and then see what is the performance of our model. Okay, like that. Okay, so we are doing the prediction. Okay, then for the then we see in the train data set. This is our a table for train, and then see what is the performance for that. Like that. Okay, the accuracy is 0.28, and we can see the ROC curve as well lah. Okay, I also would like to see for the test the test data set. Okay, and then the accuracy for that is like that. Okay, so I think and then you can like control for the parameters by choose whatever lah, mean split or mean bucket or whatever, and then look at the performance again and do one by one like that. I think that's all for my sharing. Is that okay? Sorry if not so beneficial for you all.
Saya end stream dulu.
Okay.